Could neutron stars create new elements? Imagine a factory so extreme it defies human comprehension. A place where matter is squeezed so tightly that a teaspoon would weigh billions of tons. Where the boundaries between known physics and the unknown blur into mystery. This factory isn't on Earth. It isn't even inside our sun. It's hidden in the universe's strangest stars, neutron stars. For decades, scientists have asked a haunting question: where did the universe's heaviest elements come from? Gold, platinum, uranium, rare earth metals, the ingredients of worlds, civilizations, and technology. Supernovae, the explosive deaths of massive stars, have long been seen as the answer. But a shocking twist has emerged. Evidence suggests that neutron stars, and especially their violent collisions, may be the true alchemists of the cosmos. The mystery of heavy elements. Look at your jewelry, your electronics, even the wiring in your home. Every atom of gold, silver, or platinum had to be forged in an environment powerful enough to glue protons and neutrons together against all odds. Light elements like hydrogen and helium were born in the Big Bang. Slightly heavier ones, carbon, oxygen, nitrogen, were fused in the hearts of stars. But once you climb the periodic table past iron, things get tricky. Fusing heavier elements than iron doesn't release energy, it requires energy. And so, for decades, astrophysicists puzzled. If ordinary stars can't forge these heavier atoms in large amounts, where did they come from? Supernovae were the prime suspects. When massive stars die, they collapse and explode, briefly creating temperatures and pressures high enough to smash atomic nuclei together. For a time, it seemed this could explain our universe's gold and platinum. But there was a problem. The math didn't add up. The amounts produced in supernova simulations didn't match the abundance of heavy elements we see scattered across galaxies. Something was missing. Enter the neutron star. To understand the missing piece, we need to meet one of the strangest objects in existence, the neutron star. A neutron star is born when a massive star dies. Its core collapses under gravity with such ferocity that protons and electrons are crushed together, forming neutrons. What's left behind is a stellar corpse, just 20 kilometers across, but more massive than our sun. A teaspoon of neutron star matter would weigh about 4 billion tons. Its magnetic fields can be 1 trillion times stronger than Earth's. Its surface gravity is so intense that falling a single centimeter would be like dropping off a skyscraper. These stars are beyond bizarre. Some spin hundreds of times per second, emitting beams of radiation like cosmic lighthouses. Others exist in pairs, locked in a deadly dance with another neutron star. And it is in these extreme environments that the secrets of element creation might be revealed. The R process, cosmic alchemy. At the heart of this story lies the R process, short for rapid neutron capture process. This is the mechanism scientists believe forges the universe's heaviest elements. Here's how it works. Atomic nuclei capture neutrons at lightning speed. These unstable, neutron-rich nuclei then undergo radioactive decay, transforming into stable heavy elements. Gold, platinum, uranium, thorium, all born through this exotic process. But the R process requires extraordinary conditions, a flood of free neutrons, temperatures and pressures high enough to drive rapid reactions, and environments violent enough to seed these elements into space. For decades, scientists asked, where in the universe could such extreme conditions exist? Supernovae seemed like a candidate, but the numbers fell short. Neutron stars, however, offered something even more promising: the power of collisions. Now imagine two neutron stars orbiting one another. Each is a city-sized core of ultra-dense matter, circling faster and faster as gravitational waves carry away their energy. Eventually, they spiral together and collide in a titanic explosion. This event is called a kilonova. It is brighter than an entire galaxy for a brief moment. And in that cosmic flash, the universe's true alchemy may occur. When neutron stars collide, chunks of neutron-rich matter are ejected into space. This debris provides the perfect environment for the R process. In the aftermath, clouds of freshly forged elements expand across space, seeding galaxies with heavy atoms. In fact, scientists now believe that a single neutron star collision can produce more gold than all of humanity has ever mined from Earth. The breakthrough observation. For years, neutron star collisions were only theoretical. Then, in August 2017, everything changed. LIGO and Virgo, gravitational wave detectors, picked up a ripple in space-time. The signature was unmistakable: two neutron stars merging 130 million light-years away. Just 1.7 seconds later, telescopes across the world caught the light of the explosion. For the first time in history, humanity had witnessed a kilonovae. The spectra of that light carried a hidden fingerprint, the signatures of newly forged heavy elements: gold, platinum, lanthanides. The smoking gun of cosmic alchemy. It was proof neutron star collisions don't just happen. They create neutron stars as element factories. The 2017 discovery was a turning point. Suddenly, the theory that neutron stars could create new elements became far more than speculation. Astrophysicists calculated that if kilonovae occur frequently enough across cosmic history, they could account for nearly all the heavy elements we see in the universe today. From the gold in wedding rings to the uranium in nuclear reactors. But questions remain. Do supernovae also contribute? Could exotic phenomena inside individual neutron stars, like starquakes or magnetic eruptions, forge rare elements without needing collisions? The jury is still out. But what's clear is that neutron stars are not just dead remnants of stars. They are active players in the story of matter. The gold in your pocket. Let's bring this back down to Earth. Take the gold in your ring or the platinum in your electronics. Those atoms are older than the Earth itself. They were created in an event so violent it warped space-time. Billions of years ago, a pair of neutron stars collided somewhere in our galaxy. The explosion scattered heavy elements into space. Those atoms drifted, mixed with clouds of gas, and eventually became part of the solar nebula that formed our sun and planets. When Earth coalesced, those cosmic fragments became locked inside its crust. And eons later, humans mined them, shaped them, and wore them as symbols of wealth and love. Every piece of gold is a message from the stars. Every atom a relic of cosmic violence. Beyond gold, exotic elements. Neutron star alchemy isn't limited to gold or platinum. It may also be responsible for uranium, thorium, and other radioactive elements that power the heat inside planets. Without these elements, Earth might not have plate tectonics or a magnetic field. Life itself may have depended on them. Even rarer elements, critical to modern technology, such as neodymium, used in powerful magnets, may trace their origins back to neutron star collisions. Your smartphone, your laptop, even space telescopes may all owe their functionality to ancient kilonovae. The deeper mystery, yet the mystery deepens. Not all galaxies show the same abundance of heavy elements. Some dwarf galaxies, like Reticulum 2, seem unusually rich in R-process elements, as if a single neutron star collision seeded them long ago. This raises a profound question. Is our solar system's wealth of heavy elements the result of cosmic luck? Was a nearby kilonova billions of years ago the reason Earth became habitable? In other words, are neutron stars not just factories of matter, but also silent architects of life? The future of discovery. The story is far from over. New observatories are preparing to catch more neutron star mergers. Gravitational wave detectors will grow more sensitive. Space telescopes will map the chemical fingerprints of kilonovae in greater detail. Each new detection will refine our understanding. Perhaps we will even uncover exotic forms of matter in neutron stars themselves, like strange quark matter that could rewrite nuclear physics. One thing is certain: the next decade will reveal whether neutron stars truly created the bulk of the universe's heavy elements, or if other processes share the stage. The cosmic alchemists. So, could neutron stars create new elements? The evidence points to yes. Not only can they create them, but they may be the primary source of the universe's heaviest and most precious materials. Every ring, every coin, every piece of technology built with rare metals is a relic of these cosmic events. When you hold gold, you are holding the ashes of a neutron star collision. The universe is not just a collection of stars and planets. It is an engine of creation. And neutron stars, strange and terrifying as they are, may be among its greatest artisans. The next time you look at a piece of gold, remember, it was not made on Earth. It was not made in the sun. It was born in a collision so powerful it shook the fabric of space-time. It is a gift from the cosmos itself,